Smart Tire Company, in collaboration with NASA, has developed metal-shaped memory airless bicycle tires, now available for purchase via Kickstarter. These tires are not truly airless but hollow, eliminating the need for pressurized air to maintain their shape. The key component of these tires is a shape memory nickel-titanium alloy spring called nitinol, which offers strength like titanium and elasticity like rubber. Nitinol allows the tire to deform under pressure, and then return to its original shape, providing a smooth ride, similar to pneumatic tires. The tire features transparent sidewalls and replaceable tread, with significantly less rubber than traditional tires. The main tire is expected to last for the bike's lifetime, while the tread may need replacement every 5,000 to 8,000 miles. Future versions may allow users to adjust tire firmness by adding air, making them semi-pneumatic. Pledges of $500 on Kickstarter will provide backers with a set of 2 metal tires, with retreading costing around $10. Touchwind has developed an innovative single-blade floating wind turbine for offshore applications, aiming to reduce costs and downtime. Offshore wind resources in deep waters offer significant clean energy potential, with fewer drawbacks than onshore wind farms. The design features a massive single-piece rotor on a pole draped over a large barrel, with a buoy hanging beneath it. This single-blade design is estimated to cost around 30% less to manufacture than traditional triple-blade turbines, and does not require expensive active blade pitch control systems. Unlike most standard turbines that shut down in high winds, this design is rated for speeds as high as 70 meters sec, 252 kilometers per hour, 157 miles per hour, leading to less downtime and increased energy production. The blade tilts and adapts to wind speeds, reducing its exposure to strong winds while maintaining stability. The design is agnostic to wind direction, automatically orienting itself for optimal energy generation. Touchwind believes the design can be manufactured and deployed easily from harbor facilities, making it a potentially cost-effective solution for offshore wind energy generation. A Swiss student team, Academic Motorsports Club Zurich (AMZ), has set a new world record for the fastest accelerating electric vehicle (EV). Driver Kate Maggette achieved 0 to 100 km per hour, 0 to 62 miles per hour in just under 1 second, breaking the previous record of 1.461 seconds, set in September 2022. The AMZ team used a lightweight electric go-kart named Mython, weighing 140 kilograms, 309 pounds, and powered by 4 hub motors, providing 240 kilowatts, 326 horsepower. The key to their success was an innovative vacuum fan system that creates substantial downforce, improving traction even at a standstill, and allowing for rapid acceleration. Maggette experienced acceleration forces of nearly 3 grams during the record-breaking run. Guinness World Records has certified these impressive acceleration figures, and the team believes this record will stand for a while. The AMZ team has a history of setting world acceleration records with their EVs dating back to 2014. Researchers from RMIT University in Australia, in collaboration with the University of South Australia, have developed an innovative antimicrobial approach, using nano-sized flakes of black phosphorus, BPNFs, to combat wound infections caused by drug-resistant superbugs. Black phosphorus is a stable form of phosphorus that consists of 2D layers, and has recently been identified as an effective antimicrobial agent due to its ability to produce reactive oxygen species when exposed to the atmosphere, which helps destroy bacterial cells. In experiments, BPNFs were tested on common bacteria, including drug-resistant S. aureus P. aeruginosa, and E. coli, leading to over 99% bacterial cell death within 24 hours without damaging other cells. BPNFs also self-decomposed after eliminating the infection. BPNFs were found to be comparable in effectiveness to the antibiotic ciprofloxacin in clearing S. aureus in mouse wounds. Notably, BPNFs demonstrated enhanced wound healing and tissue regeneration, with wounds closing by 80% over 7 days. This suggests that BPNFs promote wound healing, even when infections are present. The researchers emphasize that BPNFs can be incorporated into various materials, making them suitable for use in wound dressings, plastics, gels, and medical devices. Saab has developed the ultra-lightweight camouflage screen, ULCAs, a net designed to hide soldiers from radar scans, while still permitting GPS signals and radio communications. ULCAs features a color pattern and 3D surface structure that helps soldiers blend into their surroundings and blocks infrared detection. The original ULCAs net absorbed and attenuated radar signals, making it harder to detect objects underneath, but also blocking GPS and radio communication. In response to customer feedback, Saab created the ULCA's Frequency Selective Surface (FSS) system, which employs a lattice pattern to selectively attenuate radar signals in the 1 to 100 GHz range, while allowing lower frequency signals for GPS and radio to pass through. The technology can be customized for various applications, including allowing radar signals while blocking radio signals. The U.S. Naval Research Laboratory is funding a project at the University of Central Florida, UCF, to develop a morphing hypersonic engine capable of optimizing power, thrust, and efficiency during flight. Hypersonic aircraft and missiles, traveling at speeds between 5 and 20 times the speed of sound, face severe aerodynamic challenges, prompting the need for innovative solutions. The project builds upon a 2019 NRL initiative to morph the shape of aircraft in flight, aiming to create seamless control surfaces without excessive drag or heat. UCF's team, led by Professor Kareem Ahmed, focuses on applying morphing surfaces within the scramjet engine to control airflow in the supersonic combustion environment. An aerothermodynamic model for the engine has already been developed, and the project is in the experimental testing phase, with a $450,000 NRL grant supporting the research. The goal is to create an adaptable engine configuration that can self-optimize its surfaces, maximizing performance in terms of power, thrust, and travel distance, marking a significant advancement in hypersonic engine technology. Researchers at Princeton University have developed a new and eco-friendly method for extracting lithium from brine sources, reducing the time and land area required for the process. Traditional lithium extraction involves pumping lithium-rich brine into surface evaporation ponds, which can take months to years for the water to evaporate, leaving behind concentrated salts from which lithium is harvested. The new technique uses strings made from twisted cellulose fibers, with hydrophilic cores and hydrophobic surfaces, suspended over brine-filled reservoirs. Capillary action draws brine up the fibers, and the hydrophobic surfaces promote quick evaporation, resulting in the formation of lithium chloride and sodium chloride crystals on the strings. Lithium salts crystallize toward the top of each string, while sodium salts crystallize toward the bottom, due to differences in solubility. This method yields usable lithium within less than a month, requires only 10% of the land compared to traditional ponds, and can be used in various locations with lithium brine deposits. The researchers are working to enhance the efficiency of the technique, and have established a spin-off company, Pirelli Incorporated, to commercialize the technology. Leatherman has introduced the Adapt Kit, a compact and versatile case designed for organizing and carrying everyday multi-tools, electronics, and essentials. The case measures approximately 8x6x4 inches, 21x15x10 centimeters, and weighs 14.4 ounces, 408 grams, making it easy to carry or place inside a larger backpack. It includes 7 zippered and open pockets, including external access and side pockets, along with loops for organizing multi-tools, driver bit sets, flashlights, pens, and charging cables. The Adapt Kit stands out by featuring a silicone work tray that fits inside the case's zippered front, providing a portable work area for tasks like working with small screws and parts. The tray can be used inside the case or removed for external use, and is ideal for multi-tool maintenance, such as oiling joints, sharpening blades, or swapping out driver bits. The case is constructed with a 500D recycled nylon shell and double diamond polyester ripstop lining, featuring weather-resistant zippers and a reinforced carry handle. Leatherman has priced the Adapt Kit at $69.95 and designed it to be compatible with a range of Leatherman multi-tools.